Start recording. So, writing a function rule. Okay, so say for example, I have xy. I have, I have to look up here. X and y. And then I have the numbers 1, 2, 3, 4. 1, 2, 3, 4. And then over here in the y column, I have 4, 5, 6, 7. And they say write a function rule for this. That's a 6, in case you can't read it. 6. Who can tell me what the rule is? How do I turn x into y, in other words? Very good. Who said that? Nick said that. Add 3. So you look at x, you look at y. What can I do to x to make it into y? So I could have said, well, maybe it's multiplied by 4, but then you check out this one. No. So I look at this one and no, I'm not multiplying by 4. Nick said I'm adding 3, and that is absolutely correct. So the rule is y equals x plus 3. Or better yet, f of x equals x plus 3. And then if I wanted to write, so say I wanted to know f of 0, what would that be? What would f of 0 be? Plug it in.
0 would be
Plug it in here.
0.
That means take 0 and put it in there for x. What do I get out?
3.
3. Okay. What would f of negative 2 be? Plug in negative 2 in there. What do I get out?
4.
What's negative 2 plus 3?
It's 1.
1. Okay? And that's all there is to it. Okay? So that's one rule. Let's do another one. Okay? Where's my... I want to get a new piece of paper. New piece of paper. I want to get that table again. Will it let me do that? Edit. File. How can I keep bringing that thing up? Let's get another table. Hold on. Where'd my table go? There it is. There's my table. Okay, so here's another one. Let's put a, here's x. And sometimes instead of x, I'll call this f of x. I'm going to put the numbers 1, 2, 3, 4 again. 1, 2, 3, 4. But now I have negative 2, negative 4, negative 6, and I don't know. We'll put question mark here. Okay? Question mark. So, look at the problem. See if someone can tell me the function rule. Huh? What?
It's times negative.
Very nice. Okay? So, what Jordan might have done, she might have tried subtracting 3, right? And then she goes, oh, 2 minus 3. Uh-oh, that doesn't work, right? So you have to try something else. So she said maybe they're multiplying. So if I go 1 times negative 2, I get that. 2 times negative 2, I get that, right?
Oh, it sounds right.
3 times negative 2, yes, I get that. So the rule is f of x is equal to negative 2 times x, which you write just like that. Y equals negative 2 times x, which you just write y equals negative 2x. You don't need a time sign in between. Multiplication is implied when they're right next to each other. So to find this one, what is f of 4? Who can tell me what f of 4 is? Britt? Negative 8. Very nice. It's just negative 2 times 4, which gives you negative 8. Okay? Questions on that? What's wrong?
Nothing's wrong. Wait, for some of you that like to show your work, you can make a table that has 3 columns and put your work in the middle, and then you have your f of x.
Yes.
Right, Mr. Lee?
Yeah. For this one, Where's my recorder?
Like if you're doing an extended amount of X value.
I know what it is.
Okay, so what's someone other George? Who can tell me what it is? Yes,
It's the number squared.
Justin. Very nice. It's the number squared. Okay. So 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16. What you go here, Justin? 25. So to write that, I would write that as y equals just x squared. Or f of x, if you prefer, which you should, is equal to x squared. Okay, one more, and then I have a couple word problems. Oh, we have to go over the homework. We'll do that at the end. Right? Yeah. Okay, so let's do one more, and then we'll get there. All right, so I should have put an X and a Y. So I didn't have to do it. Here's X, here's Y, so here's a trickier one. 2, 3, 4. Okay, so let's go 5 question mark. Look at this one. Okay, did I pause? No, I'm still going. So who can tell me, anyone tell me what the rule is here? What's the rule? You got it?
I understand. I don't really know how to word it correctly, but I know since for 2, well, it's adding 2. For 3, it's adding 4.
Yeah, it's got to be like you could plug in like the 5th number and get out an answer. Anyone? Here's a trick, okay? How much, what?
Is it multiplying by, nope, JK.
How much is it changing by from here to here each time? 3. So that's 3, right? There's a trick. If it's changing by 3 each time, it's going to have a y equals 3x in it. Now, you can kind of say, okay, if I multiply this by 3, what do I have to do to this number? What do I have to do to that answer to make it into 1? So what's 1 times 3? Hello? 3. Take, what do I have to take away to make 3 into 1? Yeah.
3x minus 2.
It is, okay? Minus 2. So that's the way, if you see one that you don't recognize, okay, and you line them up in order, 1, 2, 3, 4, and you see how much it's changing by, 3 by 3 by 3, that's your multiplier, okay? So then you go back and you say, okay, if I multiply this by 3, what do I have to do to that to change it into 1? So if I multiply 2 times 3, what do I get? Noah? Yay! Take away 2. 6 minus 2? Come on. He said 4, okay? And that's correct, and that's where that comes from. I was putting him on the spot, okay? 3 times 4. 3 times 4, Hunter. Take away 2. 3 times 5. Take away 2. 13, okay? What if I wanted f of 100? What would be that answer? F of 100. What would that be? Plug into the formula. Thank you, Nick. Okay? 298. You just take 100, you plug it in there. 3 times 100, right? It's 3 times 100 minus 2, which is 300, minus 2, which is 298. Okay? And that's the way you do these. Okay? Now this one, I don't think I'm going to have any on tonight's homework that tricky. Okay? But it's just like add or multiply or square and things like that. So now we're going to learn about some words, some applications of some word problems. Look at this, Miss Lindgren. Watch me go. Leader out for one. Chap, I know, okay. Chapter 5. Okay. So we're going to have some word problems. Good? And I typed them up for you, so you should write these down. Here. Good? I was going to give you a piece of paper, but that's a waste of paper. Good? 5 word problems. You're going to see a couple like this in your homework. A scale model is 1/20th the actual size of a real car. Write a function rule to model this situation. So say, for instance, I have, where'd that go? Forward, now backwards. There it is. This one. Maybe I have to take a picture of it. I guess I have to take a picture of it. Oh, I know what I need to do. Okay. So, here it comes. A scale model is 1/20th the actual size of a real car. Write a function rule to model this situation. So, say I want to know what is say you have a model, okay? This is the model, and this is the real car. So what do I do where does that 1/20th go? Does it go in front of the R or in front of the N? Before that, they would go like this, right? Because it's 1/20th of usually means multiply, 1/20th of the real thing. So say, use your equation to determine how long the model of a car whose actual length is 10 feet is, right? So I take 10, where do I plug that in? Where do I plug that in? Thank you. In there. And I get, so the model length is going to be 1/20th of 10. What's 1/20th of 10? What's 1/20th of 10? It's like 10 over 1. 1 over 20 times 10 over 1 is 10 over 20. What's 10 over 20? 1/2 what? What's the units? Feet. How much is 1/2 of a feet? How many inches? 6 inches. Okay? So a scale model is 1/20th, the actual size of the real car. So if the real car was 20 feet, the model would be 6 inches. You've seen that, and if you build models, see that? 1/20th, or on a map, it'll say actual scale is 1/100th of it, or something like that. Okay, that's how you do scaling. All right, let's look at one more. And I know you're excited about this, so we're going to do this one. Lemonade stand. This will help you next summer when you're making the lemonade stand. I love lemonade stands. Not.
You like lemonade stand?
No, because I have to sit out there in the hot sun with my kids. Sit under a tree.
Why do you
All right.
bring a fan?
Bring a fan. I need a battery power stand. Okay. You buy supplies for a lemonade stand for $15. You sell cups of lemonade for 50 cents. Write a function rule to model your profit. On my kids' case, it's all profit because they don't buy they don't spend the $15. Daddy that buys the supplies for $15. Okay? So, but anyway, who can tell me how to do this? You kind of got to set up a variable. Okay? So let P equal the profits. So we're going to put P over here. This is a function rule. Okay? And what are my costs? $15. So I'm going to subtract that at the end. Right? $15. But how much do I make for each cup of lemonade? 50 cents. So I'm going to do something like 0.50, right? Because that's half of a dollar. 50 cents is half a dollar times C for the number of cups that I sell. Okay? And that's the way I set up that equation. Now to write it in function notation, the way I write that in function notation is P of C, Jordan. P of C is equal to 0.5 C minus 15. Okay? So this means that your profit is a function of the number of cups. I should have let C equal the number of cups that you sell. Number of cups. And so this means that the profit is a function of the number of cups. So how many cups of lemonade must you sell to make a profit of $20? What goes in where? Where does that $20 go? Does it go over here or does it go over here? On this side. So this is your profit. So you put 20 over here equals 0.5 times the number of cups minus 15. How do I solve this equation? What do I do to both sides? Brian, what do I do to both sides?
Divide by 5.
No, you don't.
Divide it by
Fred, add
Add
5?
15, sorry.
Add 15 to both sides. Thank you. And add 15 to both sides. Now I have, this goes away. I get 0.5 C equals 35. And now I divide by 0.5. Now I divide by 0.5. And I get that C equals, what's 35 divided by 0.5? 20? 70 cups. You need to sell 70 cups of lemonade to make $20 if you spend $15 for your lemonade. Okay?